Hello everybody, how you doing? This is Mr. Dowse. In today's lesson, I'm going to talk about how to find the distance between 2 points using the distance formula. Now, distance is the length between 2 points. And whenever we're talking about distance or the length between 2 points, you should always get a positive value. For example, I went to school in Austin, but I live in Dallas. The distance between Dallas and Austin is about 200 miles. Not a negative 200 miles, but a positive 200 miles. And so, remembering for you going on vacation with your family, whenever you're traveling between 2 points, you're always talking about a positive values. No negative number ever came into mind. And so, anyways, this is finding distance using the distance formula. And so, this is the distance formula down here. It's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Pretty crazy equation here. We've got a square root, we've got squares, we've got parentheses and subtract signs, we've got two x's and two y values. It gets pretty crazy. Now this is distance between 2 points. And so when we're talking about 2 points here, we're actually talking about coordinates between these 2 points. So we've got a x1 and a y1, and we also have a x2 and a y2. And so these are actually going to become numbers that we plug into the equation, which will end up being one number at the very end of it. Now, a pretty crazy equation, and so I have 5 steps that I have my students do to solve this problem. And if you follow these 5 steps, it'll help you organize your thoughts and help you get the right answer. Now, there is an alternative way of finding distance between 2 points, and that is actually using the Pythagorean Theorem. I've got a video on my website at dowsehouse.com. If you go under the first 6 weeks worth of videos and you look under distance Pythagorean theorem, you can watch that video and it'll get you an alternative way of finding distance. This equation here, there's a lot of steps to it and there's a lot of math to it. Using the Pythagorean theorem, it simplifies the equation and it just makes things a little bit easier because there's just less math and less places to make mistakes. But this video is about distance formulas. Let's do a couple examples here. The first example says find the distance between -3, -2, and a 5, 8. And I'm going to look straight up here at my first step here, and it says write down the distance formula. So I'm going to write this down exactly as I see it above. So x2 minus x1 in parentheses. We have a plus sign. We have a y2 minus y1 in parentheses. Now, by writing this equation down, you're kind of just organizing things a little bit easier. You might not have this equation anywhere on your paper, and so it's just going to, again, it's going to help you organize your thoughts. For step 2, label coordinates x1, y1, and x2 and y2. So we've got x1, y1, x2, and a y2. And by labeling these coordinates here and then writing down this equation, you understand that there's going to be, these numbers are going to be plugged into this equation one time each. Sometimes when my students don't write down, they don't do this right here, and they start writing the numbers down, they'll forget one of the numbers and they'll write down one number twice, and they'll get the number wrong before they even get 1 or 2 steps into the problem. So make sure you label x1, y1, and x2 and y2. Now let's see here. Step 3 says to write down the distance formula without the coordinates. And I'll explain what I mean right here. So I'm going to not put in these x's or the y's. I'm going to leave little blank spaces for them, and you'll see why here in a moment. So I left a blank for x2 and y1, y2 and y1. And then step 3 says to substitute the coordinates in for x1, y1, and x2 and y2. I'm going to change colors to help you see this better. x2 is 5. Then we have the negative sign here. x1 is a -3. And so since I've got 2 negatives here, I'm going to put parentheses here just to separate these two. And then we have a y2 is 8, and a y1 is a -2. Now, the whole point about me making step 3 and 4 2 steps instead of one big step is to help you understand that these subtract signs and the negative signs are 2 different things. If you were to plug the numbers in here as you're writing out the equation, oftentimes people forget that there's 2 negatives here, and they'll just have one negative sign and they'll get the wrong answer right there. And so there's a reason why I split these up into 2 different steps. The last step here says to solve the equations. So I'm going to start solving the equation here. Now, I'm going to keep in mind here that since we've got 2 negatives, this is actually going to become a positive 3, and then these 2 negatives is going to make this a positive 2. And so when I start solving this equation here, that's going to be an important thing to remember. So we have a 5 plus 3. That's going to give me 8. I'm going to keep the parentheses here. I don't really need it, but you'll see why I'm going to keep the parentheses when I get to the next problem on the next page. And then we have an 8 plus 2 is a positive 10. And then we're just going to continue solving this. I'm going to go with 8 squared. 8 times 8 is 64. And then we have 10 squared is 100. And then now I'm just going to combine these two and get 164. And then when I plug this into my calculator, so the square root of 164, that gets me 12.81. So depending on how your teacher wants you to round, I'm going to have my students round it to the nearest 100th. So this gives me 12.81 is the distance between these 2 points. Now, three things I want to talk about before I jump on to the next slide. Three places where people might make mistakes. First of all, keep in mind that we have a square root following us all the way down. And so the last step is always to square root a number. Oftentimes, students will get to right here, and they'll forget the square root sign, and they'll say the answer is 164, which is not the correct answer here. So the answer is going to be 12.81. Another thing you need to keep in mind is I could have called this x2 y2 and an x1 y1, and I still would have gotten the same answer here. These numbers would have been switched around, but you still would have ended up with the same distance. So if you label this one x1 y1 and this x2 y2, you're still going to get the same answer. The third thing I need to point out is you're going to be tempted to skip some steps here. There's a lot of work happening here. But if you don't quite understand how this works and you jump into this pretty quickly without getting the right answers, you're going to start making simple mistakes and you're going to get the wrong answers. Wait until you start getting the right answers, a couple problems at a time. So maybe you get this correct 1, 2, 3 times in a row. Then if you feel comfortable after that point, you're welcome to start skipping steps here. But if you get the wrong answer here and you're skipping steps, plug in those steps again and then work it out, and it will probably help you get the right answer. So please don't rush yourself here. That's where a lot of my students make mistakes. Anyways, last step we have, last example we have here is find the distance between 5, 1 and a negative 2, 4. So write down the distance formula is the first step. So I'm going to write that down. So we have x2 minus x1 squared, and then we have a y, oops, oh my goodness, sorry I went back too far. We have a y2 minus y1 squared. Step 2 says to label the coordinates. So I'm going to go with an x1, y1, x2, and a y2. And then it says write down the distance formula without the coordinates. So I'm going to leave out those numbers and I'm going to put blanks into the equation. Step 4 says to substitute the coordinates in for x1, y1, x2, and y2. So I'm changing colors to help you see this a little bit better. X2 is a negative 2. X1 is a 5. Y2 is 4. And Y1 is 1. And then the last step here says to just solve the equation. So I'm going to start solving this. Now remember, we don't have negative numbers in for my first coordinate, so we're not going to have double negatives here. And so you're not going to have this switch signs like I did in the last problem. So let's keep solving this here. So I have negative 2 minus 5 is actually a negative 7. And then I have a 4 minus 1 is a positive 3. And then I put the parentheses here because I want you to understand this is a negative 7 times a negative 7. The two negatives here is going to make this end up being a positive 49. So not a negative 49, a positive 49. And then I have 3 squared gives me 9. So whenever we have negative numbers in the parentheses here, you're going to always end up with a positive value. So these squares in this equation is what makes the distance formula end up being a positive value. And so right here, if you have a negative number, you should have ended up with a positive number, so you want to go back and double check your work. Now the square root of 49 plus 9 is going to be the square root of 58. And if I plug this into my calculator, square root of 58, I get 7.62. So if you're rounding this to the nearest hundredth, that's 7.62. And this is the distance between these two coordinates. So anyways, hopefully this helps you understand how to find the distance between 2 points using the distance formula. And have a good day. Bye-bye.